Hello everyone, welcome to Chapter 3, Equations and Inequalities. In this chapter we're going to be looking at solving simultaneous equations, algebraically and graphically, solving inequalities and sketching inequalities. And in this chapter there is little new content since GCSE. First of all, we're going to start by looking at inequalities and linear inequalities to begin with. So these examples I'm going to go through aren't in the notes, so feel free to make notes if you need. It's telling us to solve the following inequality by finding a range of values that satisfy it. So here we have an inequality, there's an inequality sign, and we're going to solve it like we would solve an equation. So I'm going to minus 3x from both sides. And then I'm going to add 6 to both sides. And then I'll divide by 2. So here we have a solution, and it is x is less than or equal to minus 4. So we actually have a range of solutions for what x can be. So it can be equal to minus 4, minus 5, minus 6, minus 10, all the way to negative infinity. We can illustrate this on a number line. So I'm just going to go down in 2's. And I'm going to have a dot above the minus 4, and it's going to be a closed dot to show that the minus 4 is included in the inequality. So we use a closed dot when we have greater than or equal to signs or less than or equal to signs. Then I'm going to have a line with an arrow to show that x can be any value from minus 4 all the way to negative infinity. Let's have a look at another one. 4 minus 2x is less than 10. I'm going to start by minusing 4 from both sides. And then I'm going to divide by minus 2. Now you may remember this, when multiplying or dividing by a negative, we actually need to change the sign around. So it's just going to turn around. So dividing by minus 2, we will get x is greater than minus 3. So showing this on a number line, I'll have a dot above the minus 3, and it's going to be open to show that minus 3 is not included. So you use an open dot when you've got greater than or less than signs. Then I'm going to have an arrow going to the right with the line to show that x is greater than minus 3, so anything above minus 3. Let's have a look at this one. Now we've actually got two inequalities here. We could solve that and that separately. Then you could draw them on the number line and see where the overlap is. We're going to look at one of those later on. I'm actually just going to solve this all at once. So when I'm adding 1, and I say add 1 to both sides, I'm actually adding 1 to this side, here, and this side. So adding the 1, we'll get 6, then we'll have 3x in the middle, and then we'll have 15 at that side. Then let's divide everything by 3. So I'll have that. Showing this on a number line then, I'm going to have a dot above the 2, and it's going to be a closed dot. And I'm going to have a dot above the 5, and it's going to be an open dot. Then I'm going to put a line in between the 2. And this shows the inequality which is above, and that is that x is greater than or equal to 2, but less than 5. So if we're actually looking at the integer values for this, x can be equal to 2, 3, and 4. Okay, this section is in the notes and we can write solutions in set notation, and you will be expected to give your answers using set notation sometimes. So here we've got a solution, x is greater than 4. To write it in set notation, we have a curly bracket, x, a semicolon, x is greater than 4. And this reads as the set of all values x for which x is greater than 4. Over here, we're going to do the same thing. So x dot dot x is less than or equal to -2. And again, that can read as the set of all values x for which x is less than or equal to -2. Let's have a look at some examples of these then. So the first one, 2x plus 1 is greater than 5. I'm going to solve it first. So -1 from both sides and then divide by 2. And the solution set will therefore be that. For the second one, I'm going to go to the bottom for a bit of space because I've got to expand both sides. So expanding the left, I'll have 3x minus 15 is greater than or equal to 5 minus 2x plus 16. Then let's add 2x to both sides. And I'm going to combine the 5 and the 16 together to get 21. Then let's add 15 to both sides and divide by 5. Now I can leave the solution like that, or you can write it in decimal form, and the solution set is going to be that. Let's go to the final one. I've got minus x is greater than or equal to 2. Now, I don't want a negative x, I want a positive x, so I'm going to multiply everything by -1. Remember, when multiplying by a negative, the sign will change, so I'll have x is less than or equal to -2. And then the set is going to be that. So we can have more than one inequality, and these are shown on a number line. So let's find the solution from the number line and then write it in set notation. So here I've got a -3 and a 2, and x is going to be between these. So it can be 2, but it can't be -3. So I will write it like that. So x is greater than -3, but it's less than or equal to 2. And when you have inequalities like this, so when they look like this on a number line, the signs do tend to point to the left, so you can use that to help you if you need. So the set can be written as this. Let's move on to the bottom one. So I'm going to have x is less than or equal to 5, or x is greater than 7. So in set notation, we're going to have to use the union for or, so it's going to be a U shape. And you may have seen this when you are working on Venn diagrams. So this represents the union and it means or. So it would look like that. We could have used the intersection, which is the and split these inequalities up with two separate sets. So we could have done the intersection for the first example, but I'm going to leave mine like that. So let's have a look at combining inequalities now. So we've got to solve each inequality and find the range of values that satisfy both. These examples are in the notes. So you could go ahead and expand for this one and then move things around, but I've noticed that 5 goes into minus 25 quite nicely. So I'm going to be left with x minus 2 and minus 5 there when I divide both sides by 5. Now I'm going to add 2 to both sides, and the solution for that will be this. X is greater than or equal to minus 3. And over here I'm going to do everything at once, so I'm going to take 3 from both sides. Then I'm going to divide by 4. And this will be the solution for that one. So on the number line then, I will just go up in 2s. I'm going to draw both. So for this one, x is greater than or equal to minus 3. Minus 3 is going to be here. I'm going to have a closed dot and then a line with an arrow to show that x can be greater than minus 3 or equal to it. And then for this one, x is between minus 6 and 1, but they are not included. Sorry, minus 6 and 1, and they are not included. So I'm going to have open dots and a line between the two. And then I'm looking at the overlap now, so where both these inequalities overlap, and they overlap here and here. So if we're finding a range of values that satisfy both inequalities, so this and this, the range of values is going to be between minus 3 and 1. And the minus 3 is included and the 1 isn't. So this is the range of values. And we can write it in set notation if we need. Okay, I've done a few examples there, so you can pause the video and have a go at these questions. If you're needing a little bit of help, these actually come from exercise 3D on page 48, and it's question 3, A, B, C and D. This is actually the end of the video.